we discuss about the problems on Swinburne test and also speed control methods and also torque, gross torque, sharp torque, all these things. That means total problems in DC motors must be covered already. Even though today class also we discussed some more problems on swing test. One problem discussed on brake test also, and some more problems on efficiency, losses, speed control, whatever it may be, right? So go for the problems. So already these problem, all problems are discussed already. So problem 10 already discussed in the last class, right? So from this problem only series motor problem. So torque proportional to Ia square, right? So for this problem also discussed. Now go for the next problem. That is the 11th problem. It is related to the brake test on a DC motor. So generally brake test is applicable to small motors only. For big motors it is not applicable to. It is a direct method, right? Direct method means we don't calculate losses separately. We don't calculate losses in the brake test. We just calculate input and we just calculate output and then determine the efficiency of a DC motor. So how can you calculate the input? So we know the terminal voltage, we know the load current. So V into IL is nothing but input power. But coming to the output power, so we know the well-known formula. The formula, the relation between the power and torque, that is P output power equal to 2 pi NT by 60 watts, right? 2 pi NT by 60. Now we don't know 2 pi N and by 60, all are known parameters. Why? Because the given speed, we know the constant values, right? But we don't know torque value. For that torque value, again, torque is equal to, so practically the torque is the difference between the spring constant, that is S1 minus S2 or W1 minus W2, whatever it may be, multiplied by the values. That means the values in kgs that may be converted into newtons means multiplied by 9.81. So 9.81 W1 minus W2 and the value of 0.375 is nothing but radius. So W1 minus W2 9.81 into W1 minus W2 into R, Newton meter, right? And on that way we have to calculating the torque. After then calculating the output power 2 pi NT by 60, and already the given input power, input voltage and input current. That's why input power is nothing but product of voltage and current. Now calculate the efficiency with the help of ratio, with the help of formula, that is a ratio of output by input into 100, that is percentile 100, right? We are getting the efficiency. Simple problem. Brake test problem is nothing but simple. So just calculate the spring difference, spring balance difference, that may be converted in kgs, that may be converted into 9.81, that is nothing but converted into Newton meters. So therefore torque is equal to 9.81 into S1 minus S2 or W1 minus W2 into R by 2, right? Radius of the brake drum. So once you are coming to the lab, so you can doing that experiment. On that time you can easily understand the experiment in theoretical also. So coming to the problem, in a brake test The effective load on the branch pulley is nothing but a square. That means taking the square radius. That means circle radius like that. Breakdown, mechanical breakdown. So on the branch pulley was 38.1 kg. Effective load. You are putting the load on the breakdown with the help of springs, moving the brake that may be fit the motor. That means that may reduce the motor speed. Mechanical brake. The effective diameter of the pulley, the given diameter. We have to, in our problem, in our formula, radius is there. That's why. So effective diameter of the pulley is 63.5. Radius is nothing but d by 2, diameter by 2, that is 63.5 divided by 2. The motor took 49 amperes at 220 volts. Motor took 49 amperes, that is nothing but IL is equal to 49 amperes, right? And voltage, terminal voltage is 220 volts. Now calculate the output power and efficiency at this load, right? First note down the all values. Effective load, that means effective load is in the sense, so W1 minus W2 or S1 minus S2. Suppose they given separately, S1 is equal to 40, S2 is equal to 2. That means 40 minus 2, 38 kgs. On this manner, we have to determine the effective load in the laboratory, practically. So separately, we have to calculate S1 or W1. Separately, we have to calculate S2 or W2, and then getting the effective load on the motor is nothing but difference between the two springs, the values S1 minus S2, or otherwise W1 minus W2 in kgs. So here effective load is nothing but W1 minus W2 is equal to 38.1 kg. They given, right? And radius diameter by 2, 0.635 by 2, that is 0.3175 meters. Now shaft torque. So torque is nothing but, so product of, generally what is the torque definition? Product of force into radius, right? Torque is nothing but product of force into radius. So force is nothing but effective load weight, that is 38.1 in, that is in kgs. Radius in meters 0.3175. So 38.1 into 0.3175 kg per meter. But torque is in Newton meter. So that's why kg meter must be converted into Newton meter. That may be available with the help of 9.81. So shaft torque is equal to 9.81 into 38.1 into 0.3175. So we are getting torque is equal to 118.6 Newton meter, right? Determine the power output. Output is nothing but 2 pi nt by 60. Generally output is equal to T into W, angular velocity. Power output is equal to torque into product of torque and omega. Omega is nothing but not W. This is the W is the weight, but omega is nothing but angular velocity in radians per second. So that may be converted into RPM is nothing but 2 pi nt by 60. Omega is equal to 2 pi n by 60. Generally, omega equal to 2 pi n by 60 is nothing but RPM, revolutions per minute. So 2 pi nt by 60. 2 pi. So this is the symbol 2 pi n. So suppose they given n or not, no problem. Total RPS, right? They given directly in RPS. So we don't put by 60. Suppose the speed is in RPM, then we go for the formula 2 pi nt by 60. Suppose they given RPS, revolution per second. Already in formula also revolution per second, the 60. 2 pi n, 2 pi into n t, 2 pi n t. We don't take by 60. Why? Because speed in RPS. Suppose in problem speed in RPM, we go for by 60. 2 pi nt by 60. 2 pi n is 12 into t, that is 118.6 by 60. If it is RPM, it is in RPS, that's why you don't take by 60. 2 pi nt is enough. So 2 pi n 12 t 118.6. Now the value is 8945 watts. Calculating this one, 8945 watts. And calculating the motor input, right? Motor input is equal to 49 into 220. What is the 49? IL, current, load current. Motor is taken current from the electric supply. That is the 49 amperes. The voltage is 220 volts. So multiplication of the 2. This is the nothing but input. Therefore, efficiency equal to percentage efficiency equal to output by input into 100. So that is nothing but 8945 divided by 49 into 220. After calculating that ratio, so we are getting 0.83. In percentile, multiplied by 100, that is 83%. So 83% of motor efficiency is available, so for brake test, right? In this way, you have to calculating the efficiency from the brake test. Once you are coming to the offline classes and laboratory experiments will be done, so that may be very helpful to the to calculating the in lab also. We have to calculate the lab theoretical calculations, right? That may be helpful. First, we have to calculate the difference effective load, that is S1 minus spring balance values, that is measuring kgs, S1 minus S1 S2. Otherwise, directly effective load is nothing but S1 minus S2. After then calculating the torque, radius, pulley radius, they are available in the nameplate details, right? So calculating the torque. So with the help of formula 9.81 into S1 minus S2 or W1 minus W2 into that radius R. After calculating the torque, we go for the power output, that is 2 pi nt by 60 if n is RPM, 2 pi nt if n is RPS. In our problem, n is RPS, that's why we go for 2 pi nt is enough for power output. 2 pi is the constant, n is the given RPS 12, and T is we have to calculate already, that is 118.6 Newton meter, right? Calculating the input and output. So go for the efficiency, that is the ratio of output by input. So getting 83%, right? Next problem. This is the this problem is related to Swinburne test. Already, so last class first problem discussed the Swinburne test. So what is the difference between direct test and indirect test? That is brake test and Swinburne test is nothing but both are calculating the efficiency. But in brake test, we don't calculate the losses separately. Copper losses, constant losses, total losses, combination of both those two. But coming to the Swinburne test, experiment is very easy. Just calculating the just put the motor in rated position with the help of rheostat. After then, note down the readings of voltmeter, ammeter and field ammeter. IL and IL, that is all no load values. We don't put any mechanical load on the motor in Swinburne test. That's why that is indirect test. Indirect test, we have to calculate losses separately. First, we have to calculate the constant losses. WC is equal to VI naught minus IA naught square RA. So no load input power minus copper losses. This is the no load copper loss. This is the constant. That is the constant losses is same for all type of loads. After then we have to go for the loaded condition. Calculate the losses, copper losses. So right, after then combine constant losses and copper losses. This is the total losses. Now finding the motor input. Input minus total loss is nothing but output. So output by input in the sense efficiency. Right? For Swinburne test, first you have to calculate the no load losses. That is nothing but no load losses in the sense constant losses. First we have to calculate the constant losses. Then we have to calculate the copper losses, combine both two losses, then calculating the input power minus losses, total losses is nothing but output. So output by input is nothing but efficiency, right? Go for the problem. The no load test of a 44.76 kilowatt 220 volts DC shunt motor gave the following figures. Input current 13.25 amperes, field current 2.55 amperes, right? Resistance of the armature 75 degrees centigrade. Resistance of the armature at 75 degrees is 0.032 and brush drop is 2 volts. Estimate the full load current and efficiency. That means you have to calculate the full load current and also efficiency. So as you know, already discussed the Swinburne test, right? First you have to calculate the constant losses. Constant losses is nothing but input no load input power minus no load copper losses. So what is no load input power? So first input no load input power is nothing but no load voltage, no load current. So already they given 220 into 2.5. This is the 220 volts and field current, that is the ISH naught or IL naught, whatever it may be, 2.5. So that may get 540 watts. This input meets the all kinds of no load losses, that is armature copper loss and constant losses. So therefore ISH is equal to V by RSH, 220 by 200, 1.1. Therefore no load armature current IA naught is equal to IL minus ISH. IL 2.5, ISH 1.1, that is nothing but 1.4. Now right, we know the no load armature current. Now find the no load armature copper losses. IA naught square into RA, that is 1.4 square into 0.8, 1.6. We know the input no load input power, we know the no load copper losses, then can calculate the constant losses. Constant no load or full load, whatever it may be, both are same. Constant losses is equal to no load input power minus no load copper losses. What is the no load input power? So 550 watts. What is the no load copper losses? 1.6. Now difference of the two is nothing but 548.4 watts. That is the constant losses. These constant losses are same throughout the load variation, throughout the operation of the motor. There is no change. So Swinburne test is nothing but first we have to calculate the constant losses. What is the constant losses formula? No load input power minus no load copper losses. What is the no load input formula? V into IL. What is the no load armature copper losses? IA naught square RA. How can you find out the IA naught? Armature current at no load, that is nothing but IL minus ISH. IL they given, ISH you have to find out, V by RSH, right? 2.5 minus 1.1, that is nothing, this is equal to 1.4 amperes. We easily find out the armature copper loss IA naught square RA. Then subtracting the no load input power minus no load armature copper losses, that may gives the no load constant losses. So one subtopic is completed. Now calculating the load armature copper losses, right? So now input current is 20 ampere, that is load current is 20 amperes, right? Now IA armature current is what is the resistance, full load current and efficiency, 20 amperes. So how can you find out the IA is equal to IL minus ISH? Now we don't know ISH is there 1.1, that is not changed, but what is the IL value? So IL value is equal to power by VL. The given power 44. I'm not putting this slide. So PL is equal to VT into IL. Therefore IL is equal to PT by VL. What is the power? 44.76 into 10 cube divided by 220. That is nothing but 32 amperes is the IL. Therefore armature current is equal to IL minus ISH, that is the motor. IL 32, ISH is 1.1 for no load or full load, whatever it may be. So 30.9 amperes. Now calculate the armature copper loss at loaded condition. What is the armature current at loaded condition? 30.9. Now IA square into RA, 30.9 square into 0.8, that is 764 watts, right? So we know the constant losses, we know the copper loss at loaded condition. Now both are adding, we are getting the total losses. Total losses is equal to constant losses plus loaded copper losses, that is 764 plus 548.4, that is equal to 1312 watt. 1312 watt approximately. Now calculate the input V into IL. V 220, IL 20 amperes. That is nothing but 4400 watts, right? Now output is nothing but input minus total losses, right? Input 4400 minus total losses 1312. Therefore output is 3088 watts. Therefore we know the input, we know the output. So efficiency in percentile, output by input into 100, output 3088 by 4400. So we get the 70.2%, right? So after calculating the efficiency, what we have to observe? Suppose in spin-burn test, that may be running a generator or motor, whatever it may be. So now you have to calculate motor calculation. Suppose if it is a generator, here put IA is equal to IL plus ISH, that is 32 plus 1.1, that is 33.1. If it is 33.1, copper losses are increases, right? Copper losses increase, that is 31.1 square into 0.8, and then calculating total losses, and then input and output efficiency. So generator efficiency is more than the motor efficiency. Why? Because so losses are increases means generally denominator factor is reduces, such that efficiency may be increases. So generator compared to motor, generator efficiency is more, right? So from the above problem, so you have to observe some of the points. Mechanical losses remains constant, that is nothing but constant losses remains constant throughout the motor speed changes from no load to full load, whatever it may be. If it is a no load or it is a full load, the losses are 548.4 watts. That's why that value is directly added in the loaded condition also. Point. Effect of armature reaction on main pole flux with consequent changes in iron losses has been neglected. Armature reaction మనం నెగ్లెక్ట్ చేయమంటున్నాడు. ఎందుకంటే ఆర్మేచర్ రియాక్షన్ అంటే ఏంటి? ది ఎఫెక్ట్ ఆఫ్, మనకు రెండు ఫ్లక్స్లు ఉంటాయమ్మా, ఆర్మేచర్ ఫ్లక్స్, ఫీల్డ్ ఫ్లక్స్. మెయిన్ ఫ్లక్స్ ఏంది? ఫీల్డ్ ఫ్లక్స్. ఫ్లక్స్ ఎక్కడి నుంచి ప్రొడ్యూస్ అవుతుంది? ఫీల్డ్ నుంచి. అందుకని అది మెయిన్ ఫ్లక్స్. ది ఎఫెక్ట్ ఆఫ్ ఆర్మేచర్ ఫ్లక్స్ ఆన్ ఫీల్డ్ ఫ్లక్స్ ఈజ్ నథింగ్ బట్ ఆర్మేచర్ రియాక్షన్. దానివల్ల ఏమవుతుంది? ఒక ఫ్లక్స్ ఇంకో ఫ్లక్స్ మీద ఎఫెక్ట్ అవడం వల్ల టోటల్ ఫ్లక్స్ రెడ్యూస్ అవుతుంది. ఫ్లక్స్ రిడక్షన్. ఆర్మేచర్ రియాక్షన్ వల్ల ఏమవుతుంది? ఫ్లక్స్ రిడక్షన్. ఎప్పుడైతే ఫ్లక్స్ రెడ్యూస్ అయిందో స్పీడ్ ఏమవుతుంది? ఇంక్రీజ్ అయిపోద్ది. కానీ మనకేం కావాలి? ప్రాక్టికల్గా లోడ్ వేసే జనరల్గా స్పీడ్ తగ్గాలి. సో దట్స్ వై ఎఫెక్ట్ ఆఫ్ ఆర్మేచర్ రియాక్షన్ ఈజ్ నెగ్లెక్టెడ్. Decrease in flux due to increase in shunt resistance by heating has been neglected. ఫ్లక్స్ రెడ్యూస్ అవ్వడం వల్ల లాస్ వస్తాయి, ఎందుకంటే రెసిస్టెన్స్ అనేది ఇంక్రీజ్ అవుద్ది. దానివల్ల ఏమవుతుంది? హీట్ ఎక్కువ ఏర్పడుద్ది. ఆ హీట్ వల్ల లాసెస్ వస్తాయి. వాటిని కూడా నెగ్లెక్ట్ చేయండి. అంటే ఈ లాసెస్ అన్ని, ఈ పాయింట్స్ అన్ని మనం ఐడెంటిఫై చేసుకోవచ్చు ఫ్రమ్ ద knowledge. Like this we have to determine the all the problems also, right? So we done the problems on torque equation, we done the problems on speed control methods, we done the problems on losses and efficiency, we have solved the problems on spin burn test and also brake test also, right? So main important questions of second unit, that is DC motors, is so Speed control, explain the speed control of DC motors. That is flux control method and armature control method. Shunt motor. For series motor, there is not in syllabus. And next question is characteristics of DC motors. That is characteristics of DC motors in the sense mechanical characteristics and electrical characteristics. Right? Mechanical characteristic is speed versus torque. Electrical characteristic is nothing but torque versus IA, speed versus IA. Right? For shunt motor, series motor, compound motor. That is also most important. Speed control of motors, DC motors, characteristics of DC motors. Then another question is necessity of starter and what is the explain the construction and operation of three-phase starter. Torque equation. Derive the torque equation of a DC motor. And also explain the different losses occurred in the DC motor. Explain the indirect test of a DC motor. These are the questions. Suppose they are asking explain the significance of back EMF with a neat explain the principle of operation of DC motor circuit. They don't ask that operation of DC motor. Suppose they are asking what is the significance of back EMF, 2 marks. Otherwise define back EMF. In motor also generate reaction takes place. That is whenever a conductor cuts the magnetic field, an EMF is induced. So this EMF will always oppose to the applied voltage according to Lenz's law. So this EMF is called back EMF. EB is equal to pi Z N by 60 into P by A, or EB is equal to V minus IA RA. Right? So that topic is asking always 2 marks till now. Suppose they are asking explain the back EMF and with the help of DC motor principle operation is nothing but, so you have to explain clearly. Main questions, speed control, characteristics, torque equation, Swinburne test, 3-point starter, different types of losses occurred in the DC motor, and also condition for maximum efficiency, that is iron loss is equal to copper losses, right? Iron losses is equal to copper losses. So, and problems, mainly they are asking problems on efficiency and also torque and also speed control mainly. Sometimes they don't ask problems also, they directly given theory questions, but we may prepare both, that is questions and answers also. I mean problems also you have to clearly. So the important relations in the second unit is nothing but back EMF EB is equal to pi Z N by 60 into P by A volts. EB is equal to V minus IRA volts. Right? Next torque equation, armature torque 0.159 pi ZIA into P by A Newton meter. Shaft torque TSH is equal to 9.55 EBIA by N, otherwise 9.55 output power by speed N Newton meter. So torque is 3 types. Armature torque is equal to shaft torque plus last torque. Armature torque or gross torque same, right? Then go for the speed control of DC motor, that is from the back EMF equation, EB is equal to pi Z N by 60 into P by A volts. So N is proportional to EB by pi. N is proportional to EB by pi. So but EB is equal to V minus IARA by pi. Now I am adding extra resistance in the armature circuit. N proportional to EB minus IA into RA plus R external. Right? So right. Observe the right side of the equation, V minus IA RA plus R external divided by pi. 3 parameters are variable: terminal voltage in the armature circuit, extra resistance R external in the armature circuit, flux in the field circuit. First 2, that is voltage in the armature circuit and also extra resistance added in the armature circuit, that may related to the armature, but flux is related to the field. That's why The speed control of a DC motor is broadly classified into two methods: flux control method, armature control method. Right? Next, so main relation is n proportional to EB by pi. N2 by N1 is equal to EB2 by EB1 into pi 1 by pi 2. Suppose it is a shunt motor, pi 1 is equal to both are constant. So N2 by N1 is equal to EB2 by EB1. Suppose it is series motor, pi proportional to IA. That means N2 by N1 is equal to EB2 by EB1. So IA1 by IA2. Pi 1 बदल IA1, pi 2 बदल IA2. Right? This is series motor. Then torque relation, torque proportional to pi Ia. T2 by T1 is equal to pi 2 by pi 1 into Ia2 by Ia1, right? So if it is shunt motor, torque proportional to Ia, that is T2 by T1 is equal to Ia2 by Ia1. If it is series motor, T2 by T1 is equal to Ia2 square by Ia1 square. Why? Because pi proportional to Ia, right? And this way you have to remember all the relations and you have to derive the problem. We have to solve the problems also. Efficiency, output by input, right? For motor, you may give the output. For input. For generator, you may give the output, right? Suppose for generator, we know the output. That's why output by, we don't know input. That's why output plus total losses, constant plus copper losses. Whereas in motor, we know the input. That's why output minus total losses by input, right? That is equal to efficiency of a generator or motor. In general, the generator efficiency is more than the motor efficiency, right? So like this, we have to solve the problems on DC motors also, right? Any doubt, please ask me. So from the this class, second unit is completed. Second unit of electrical technology subject is completed. That is nothing but DC motors topic is completed. Next class onwards, we will go for the third unit, that is transformers. Any doubt, please ask me. Okay. Please ask. If any doubt, please ask me.